Hey guys, it's Eric. Just wanted to run through a couple problems of the flavor that you're going to see in the beginning of Chapter 7 of our text. So, Chapter 7 is all about what sort of samples we see when we do statistics. And so, the first exercise is to take a look at a small population and a small sample from it. And the reason we're doing small populations first is because we can actually list all the possible small samples we get from a small population. So for example, I'm on Chapter 7, number 8, which is a problem that starts on page 242, and it says, all right, suppose we have a population of 5 companies, V, W, X, Y, and Z, and they each have a certain number of sales, so I've listed that up here. The first goal in Part A is to figure out all the different ways that we could pick 3 companies. So the idea is we're going to pick 3 companies and take their average sales, and we just want to see the different ways we can do that. So I actually went through, and you need to sort of think about this, and I went through and saw that there were 10 ways to do this, and here's sort of all the ways you could do it. You could have picked VWX, you could have picked VWY, etc. Incidentally, when we talk about picking 3 companies, order doesn't matter here. So picking V, W, and X is the same as picking X, W, and V, because all we're going to do is average the 3 numbers, so there's no like first company I picked, second company I picked. And that's why there's only 10 ways to do this, if you look. And so then for each of these, I computed the averages. I didn't want to make you guys sit through all that, so I left just one left over, the last one. So just as we've done a bunch of times, I just did equals average. And this is, we're going to average X's sales, comma, Y's sales, comma, Z's sales. So that's just the same thing I did for all 10 of these. So that's actually the answer to Part B. And then C says, all right, well, let's produce a table, produce a frequency table, which is the kind of table you guys have seen before, of all the different ways we could find our averages. And if you look here, you'll see the different averages that come up. There's really only 3 flavors of average you can have. And if you notice, you see 110 a lot. What we're going to see in the next part is that 110 is actually the average here. So in a sense, if you want to think about it, every time we get a 110, that's a way we could get it sort of exactly right. And then some of the other numbers, 106 or 113, those are a little too small or a little too big. So to make this table, I'm just going to say, okay, what values do I see on this table? And so one of the values I see is the small one, the 106. Another value I see is the 110. And then another possibility is the 113, and that's all the values I might see. So that's all I'm going to do there. Now, to count how often these happen, obviously I could count these by hand, but I just want to show you guys a function that will do it for you. So if you do count if, and you say, okay, I want to take that range of cells, and I'm going to put dollar signs on them because I always want to be counting that range of cells. And then I say, count if you see this particular value. So again, it's asking for a range. What area do you want me to count? So that's the highlighted blue cells there. And then it's asking, what is it you want me to count? So I'm saying count every time you see a 106.6 there. And it comes back and says, oh, I saw that 3 times. And you look at it and go, oh, good, it's got that right. And then I can just drag and copy this. And because I put the dollar signs, it's always looking at the same range. But then for this one, it's looking in D9. So it's saying how many 113s did I see? For this one, it's how many 110s. So that's the first part of Part C. And then it says it wants a bar chart as well. So I'm sure you guys have done a bunch of these. We're pretty good at this. So I'm going to get the charts and pull up the column. Clustered column will be fine. And there we go. So it knew that freak was the word there for frequency. So it said, okay, I'm going to title it that. Notice, as we've seen before, it's giving me 1, 2, 3 because it doesn't know what the labels ought to be. So I'm going to go, all right, we need to choose data for that. There's X data labels. I'm going to say, okay, the data labels should be there. Hit OK, and there we go. It was a perfectly nice bar chart with, shows you that you got 3 of these, 4 of these, 3 of these, etc. Part D asks, if you were to choose a sample of size 3 from the company, how likely would it be that the sample would be 110? That the sample mean you got. And so that's actually proportion here. So if I look at my total, how many samples I got. Got 10, so if I wanted to look not in frequency, but if I wanted to look at a proportion chart, I could say that's equal to this E7 divided by the total, which I'll $sign because I always want to be dividing by that. And so the answer to part D is, how often would you get it right? Would you get the 110? That's the proportion of times you'd pick that, and that's the 0.4. Moving along to number 12, which says, okay, take a look at the thing you did in number 8. So obviously if I was turning this in for homework, I'd start another worksheet. It says, show the bar chart and comment on its shape. So that's the same chart I made for number 8. I just copy it over and say, oh, it looks roughly symmetric, it's centered at 110, etc. Then we get to the more interesting part. Part B says, show that the mean of the sampling distribution is equal to the population mean. So the way I've written that down is the mean of the sampling distribution is really the mean of the means you can get. So I've got 10 possible samples that I could have gotten and their means here. So I'm going to say the mean of the means, in other words, the mean of the sampling distribution, is the average of all the averages you can get. And that's 110. And the true mean, the average of the population, if I go up here and say, well, here are the numbers of the actual 5 companies, we notice that's the same. As it should be. Hopefully that's not a surprise, that if you take a bunch of samples and you do this over and over and over again, the average of your sample means should be trending towards, should have the same distribution, should be centered in the same place as your original population. But then part C says, what about standard deviation? And that's a little different. So notice in the original population, yeah, most things are 110, but you can get as high as 120 or as low as 100. In the frequency, in the sampling distribution, you're centered at 110, but you can get only as low as 106.6 and only as high as 113.3. So this is less spread out than the original. And that makes sense. So before we get started with the relationship between them, I want to start with the difference between lowercase n and capital N. So if you look in your book, you'll see that lowercase n is the number of samples you have. So lowercase n is just 3 in this case. And then uppercase n, so lowercase n is the sampling size. We're taking 3 companies and averaging them. Uppercase n is how many companies you have, how much your population comes from. And so we want the sigma of the population. That's the regular sigma over here. So that's going to equal stdev.p. It's important that you use stdev.p because you're analyzing the standard deviation of a population. And that's there like so. Versus the sigma of the samples. Now that's still a sigma, so it's still stdev.p. You're still using population because, this is where it gets a little tricky to think about, this is the population of all possible samples. Each of these is the mean for one single sample, and we have all 10 possible samples there. And it's 2.5819. So just as I said, the population's more spread out. We got this standard deviation of 6, and the samples themselves are closer together. These numbers here in the bar chart are closer together than the numbers are in the original population. So we've gone from 6.3 to 2.58. Then it says, show that the standard deviation of the sampling distribution, okay, I got that, that's my 2.58, is equal to the population standard deviation, okay, that's my 6.324, divided by the square root of the sample size, okay, so that's my lowercase n, square root of lowercase n, multiplied by the FPC. And if you look on page 248, I've actually copied the formula here. The FPC is this ugly looking square root. Now, part C isn't asking you to compute a new number, it's just asking you to verify the relationship between these two numbers that you get here. So the idea is sigma of samples, the 2.58 I computed, I could have computed it a different way, starting with the original sigma and doing all this nonsense to it. So let's just see if that's actually the case. So my formula is that it's equal to regular sigma, sigma of population, divided by square root, SQRT is how to get Excel to square root, lowercase n. There's my first fraction there from the formula, times now square root capital N minus lowercase n divided by, I want to actually put that in parentheses so I can get the whole thing there, divided by capital N minus 1. Finishes that off, and then that's the one in the square root. Phew, 2.5819889. So this same number that we computed using the samples, we could have actually computed using this crazy formula to start with. So that's exactly the sort of exercise you're going to be doing for number 7 and number 11 for one of your distributions, and again for number 9 and number 13. So it's both of those problems sort of pair together in this two-step procedure. Anyway, good luck with it, and as always, if you have any questions, email me, contact me in the forums, or we can schedule an office visit. Talk to you guys later. Bye.